Hey guys, let us know about the laws of refraction of light. So before going to the laws of refraction of light, you must know about what is refraction. Guys, have you ever put your finger into the glass of water? Or have you ever put a pencil inside the glass of water? If you haven't done this, you can try it now. If you have done this, then you must have seen a bending image of your finger or the pencil. The part of the finger or the pencil which is inside the water seems little deviated from the original place, and it is not seen in the place you are expecting it to be seen. Why this happens? Have you ever thought about this? In science, what can you say this? This is a phenomenon called the refraction of light. So, when light travels from one transparent medium to another, so it tends to bend. So, this is called refraction of light. As in the image, you can see you have put a pencil into the glass of water. Here, this medium is called the air, and this is the water medium. When the light travels from air to water, it tends to bend. So this is the phenomenon of refraction. Let us give a scientific definition to it. Refraction is a change in direction of wave propagation due to a change in its transmission medium. Refraction of light refers to the change in direction of a ray of light when it travels from one medium to another. So this is the scientific definition of refraction. So there are various terms we can use in refraction. At first, we have refracted ray. It is the bent ray as a result of passing from one optical medium to another. Then you have normal. It is an imaginary line perpendicular to the interface of media where the refraction occurs. Angle of incidence. It is the angle between the incident ray and the normal. Angle of refraction is the angle between refracted ray and the normal. So let us know how we can use these terms. We can refer to this image where this is our normal. This is the perpendicular to the interface of media where the refraction occurs. So here the refraction, that means the bending of light occurs. So this is the normal. It is the imaginary perpendicular line, and it is the incident ray, the ray which is approaching to the surface of refraction. Then your refracted ray, the ray which bends, is called your refracted ray. Angle of incidence, this is your angle of incident. It is between normal and the incident ray. Then your angle of refraction, it is between the normal and the refracted ray. So now you got clear how we can use these terms. Now we will go through the laws of refraction. Your first law says that the incident ray, the refracted ray and the normal to the interface all lie in the same plane. Here you can see the image. What the first law says? It says the incident ray, the refracted ray and the normal all are going to lie in the same plane. So this is the first law of refraction. Your second law of refraction is for two given media, the ratio sin I divided by sin R is equal to be a constant, where I is the angle of incidence and R is the angle of refraction. So here I is the angle of incidence and R is the angle of refraction. Just go through the image. Angle of incidence, angle of refraction. So sin I by sin R is equal to constant. So refractive index, that is denoted by n, of a medium is given by sin I by sin R is equal to n, a constant. So what is this refractive index? We know that when light passes obliquely from one medium to another, it changes direction in the second medium. The extent to which change in direction takes place in the given set of medium is termed as refractive index. So now you got clear what is refractive index? So, the greater the value of refractive index of a medium, the greater is the bending effect of light when it passes from air to that medium. A material with a larger value of n, that means your refractive index, is an optically denser medium. So, what is optically denser medium? It is the medium in which the value of refractive index is larger. So it is called optically denser medium. So here, if the value of refractive index of a medium is increasing or is in greater sense, the greater will be the bending effect of light when it passes from air into that medium. So in simple terms, we can say denser medium to less dense medium. Then the light will bend away from normal. Less dense medium to denser medium, bend towards normal. Then, however, if the light ray enters another medium perpendicularly to the boundary, there will be no deviation of the ray even when there is change in speed of light. So, if the light ray will enter the medium perpendicular to the boundary or to the surface where the refraction occurs, then there will be no deviation of the ray even if there is a change in speed of light. So now you understand? Let us know about absolute refractive index. So refractive index, that is denoted by n of a medium, is the ratio of the speed of light in vacuum to the speed of light in that medium. Hence, n can be calculated using n equal to c by v, where c is the speed of light in a vacuum and v is the speed of light in that medium. So now you got clear how we can calculate absolute refractive index? This implies that the higher the refractive index of a medium, the slower will be the speed of light through it. So if the refractive index of that medium is high or higher, so the speed of light will be slow. So this is the absolute refractive index. This means that a medium's optical density increases as its refractive index increases. So it is very simple to understand. Now moving on to relative refractive index. So you can consider a ray of light passing from medium 1 to medium 2 as shown in the figure. So we have shown in the figure how a ray of light is passing from medium 1. This is the medium 1, that is your air, to the medium 2, that is glass. So here V1 will be the speed of light in medium 1. So this is the speed of light in medium 1, V1. V2 will be the speed of light in medium 2. So here this is the medium 2, that is glass. So V2 will be the speed of light in medium 2. So the refractive index of medium 2 with respect to medium 1 can be written as below, like n21. This is your relative refractive index. So it can be calculated by speed of light in medium 1 divided by speed of light in medium 2, that is V1 by V2. So now you got clear how can we calculate relative refractive index? Now we will know about the consequences of refraction of light. A pool of water looks shallower than it really is because the light coming from the bottom of the pool bends when it comes out at the surface due to refraction of light. A straight object placed in water looks bent at the surfaces. A straight object placed in water looks bent at the surfaces, like putting the pencil into the water. So here the pencil does not look straight. It looks bent at the surface of water. Then a pool of water looks shallower than it really is because the light coming from the bottom of the pool bends when it comes out of the surface. So this is due to the refraction of light. So here we have given an image. So here the real brick is here. The real image is here. But we see a virtual image. We see the brick to be here. A little above. So this is due to the refraction of light. Then twinkling of stars is due to refraction of light. Have you ever thought why stars twinkle? Because it is due to the refraction of light. When the light travels from vacuum to the air of earth, so it changes the direction, and then we can see the stars to be twinkling. So this is very interesting. So guys, this light chapter seems to be very interesting, and it is my favorite also. So another consequence of refraction is a line or a spot of ink on a paper always appears to be raised when viewed through glass slab due to the refraction of light. So you can try this at home also. Then your mirage. Why mirage occurs? Have you ever thought? This is due to refraction of light. How this occurs? Mirage happens when the ground is very hot and the air is cool. The hot ground warms a layer of air just above the ground. When the light moves through cold air and into the layer of hot air, it is refracted, or you can say it tends to bend. A layer of very warm air near the ground refracts the light from the sky nearly into a U-shaped bend. So this is the scientific reason why we see the mirage. But not just a mirage, but we can talk about the sunrise and the sunset. We don't see sunrise and sunset at the exact time they occur. Light takes some time to travel to Earth because here the distance is really great. That's why we see sunrise sometime after it actually happens. So guys, we just learned about a very interesting chapter of physics. You can subscribe to our website www.syft.in for more videos like this. Keep learning guys. Thank you.